Welcome back to part 2, how I built my pole barn shop. The first summer I started this project, my immediate and highest priority was to get the shop under roof as quickly as possible, as you might imagine. All the 6x6 vertical wall timbers and upper banding boards were of new treated lumber, so I wasn't worried about them. They could withstand getting wet. However, the trusses and the roof bracing were not treated, and thus they were susceptible to the elements. So as soon as they were attached to the structure, the pressure was on. I had to get that sheet metal on the roof as soon as possible. Fortunately, things proceeded quite nicely. I didn't have lots of distractions. The rain held off for several weeks, and I ultimately got the roof metal on in a reasonable period of time. Generally, as I recall, I could install about 3, sometimes maybe 4 panels screwed down in a day. Now, as you know, a crew could do that entire roof in a day, but it was just me, and that was my maximum output. And you have to remember I was 60 years old at the time. Not making excuses, just saying. In this photo, you can see where I was installing the very last piece of roof sheet metal. And just like getting the last truss installed, getting the last roof metal on was like, well, it was like a rite of passage. It was very satisfying. The ridge cap didn't go on until sometime later, but at least the roof was on. One thing I would like to point out is that not all pictures in this video series are in chronological order. This is a later photo than when I put the roof on, but I'm using it to point out something related to the roof. If you look closely at the roof, you can see that there is a thin roof underlay installed between the top of the horizontal 2x4s, the roof boards, and the underside of the roof sheet metal. It comes in a roll perhaps 1/16 inch thick by about 3 feet wide. It's sold at Home Depot, Lowe's, and elsewhere. And what it does is it provides a slight amount of insulation, but most important, it provides a vapor barrier to catch any water drops that might work through the sheet metal. And if you look at this picture, you can see a number of small white sun dots in the roof panels. That's because my outside panels were used previously and had screw holes in them from where it was previously attached. And that's what the little white dots are. Fortunately, the screws were put in at the top of ridges, so most water would flow down between the ridges. Second, I later went up on the roof and on the sides of the walls and closed in all those holes with silicone. The result is I've had no known leaks. After the shop was under roof, it immediately became a natural magnet to store things. Some of my wood piles ended up there. Also a lot of tools and other miscellaneous. Unfortunately, this created a problem because in order to work in certain areas inside, I would then have to move stuff from one location to another. That, of course, took time and energy and extended the overall build time. I later purchased a second 20-foot storage container, and that helped with some of these overflow items. Because of the inside clutter, I began to focus on projects outside this shop, such as banding the outside walls with horizontal 2x4s, to which the side sheet metal would later be attached with screws. I had 20-foot length 2x4s for that purpose. Since the side walls were 60 feet long, that meant 3 20-foot lengths were required end to end for one run. The run above it would then be a 10-foot, 2 20s, and then a 10 again. This, of course, ensured maximum wall strength by never having open butt-in joints immediately above or below one another on any particular vertical post. I also focused on closing in the gable ends of the shop, where the end trusses were located. Doing this helped use up some of the wood stacked inside the shop and thereby created more working room. However, I will freely admit that it continued to be a challenge not to store things in the shop under roof. It was just so convenient. As you can see in a couple of these pictures, I also began to install some of the white plastic soffit pieces under the eaves and gable ends. The next thing done was to begin excavation around each post, in contemplation of the concrete floor soon to come. Each of these holes were hand dug with a shovel and measured for depth using a laser level. I wanted the concrete a few inches deeper around each post because that would provide more stability for the post and also ensure more overall building strength. About that time, I was forced to move everything back out of the shop to make room for the concrete floor. That included wood, materials, tools, and everything else that was under roof. Had I to do it over again, I probably would have put the concrete floor in first and then built above it. But either way, I eventually got the concrete floor. As they say, hindsight is 2020. One of my father's favorite sayings was that preparation is 90% of every job. You've probably heard that before too. And there has never been a truer statement when it comes to installing a new concrete floor. Even though I initially had the site bulldozed for level, it still required a great deal of time tweaking various places on the floor in order to get a really close level floor area. The laser level told me where the high and low spots had to be dealt with. It didn't have to be perfect, but I wanted it reasonably close. That was followed by putting in a few inches of gravel, leveling that as well, and then compacting. I bought myself a small compactor and spent nearly a month of time compacting the gravel base. It was my goal to compact as much as possible to avoid future cracks and settling in the floor. After compacting, I next built the cement forms around the entire structure. I used old 2x12s I had on hand. Once those were installed, I hand painted the inner side with old black used engine oil to act as a release agent after the concrete was poured. And I will tell you, it worked very well. After the concrete set up for about a day, I pulled those forms off with no problem. Before finishing the floor, I deviated for several weeks to dig a trench in which water and power lines for three-way path lights from the house to the shop would be installed. What you're looking at here is the very back southwest corner of the shop where water was required for the bathroom. This line went around the west and north sides of the shop and then back into the shop, where it teed into shutoff valves and the main water line from the house. The trench around the building was about 3.5 feet deep. It was run outside the structure because I did not want to trench through the floor of the building and thereby disturb ancient compacted dirt. It may not have made any difference, but I didn't want any soft spots under the concrete where disturbed dirt might later settle. As you can see, I had begun to put some fill over the PEX line. However, I did not immediately backfill with dirt entirely because after the PEX line was in place, I planned a French drain in the same trench about a foot above the water line. That drain was necessary to allow rainwater to excavate from the south side of the building to the north side. Here you can see as the bathroom feeder line came around the corner of the shop heading along the north side to where it teed in with the water line from the house. The post laying against the trench wall served two purposes. First, since it was long, I could stand at ground level above the trench and pound down, thereby compacting the backfill. Second, it proved very useful as a weight on top of the PEX line to hold it in place while dirt was initially shoveled on top. If a weighted object was not on top of the PEX line, it would naturally twist while trying to recoil back into its shipping position. These three side-by-side photos are all looking at the same northeast corner of the shop where the bathroom line trench intersected with the house feeder line trench. It was here that the two lines would later be teed together with shutoff valves inside the shop up about 2 feet in the wall. In the far left photo, the house water feeder line has not yet been placed in this second trench. However, if you look in the middle and right photos, you can see where the house line is beginning to be put in place. Also being buried in this second trench was wire that would later power path lights between the house and the shop. This was not a wire to bring electricity to the shop. This was merely to feed path lights and allow for three-way switches to be placed in the house and the shop. In this way, I could turn path lights on at the house and then turn them off at the shop, or do the opposite and turn the path lights on at the shop and then turn them off at the house. The second house feeder water line was buried about 4.5 to 5 feet deep, and the power line was about a foot, maybe a half a foot above it. The reason this second trench was deeper than the first bathroom trench line skirting the building was to allow for any future development beside the shop. I didn't want to worry about digging down 3 feet and accidentally cutting a water or electric line, so I just dug it a little bit deeper. The house feeder trench was about 350 feet long, and when this photo was taken, I was perhaps a third of the way to completion. Rather than dig the entire trench and then lay the lines, I would dig about 20 feet, lay the lines, backfill, and dig the next 20 feet. At this point, I was perhaps 75 feet from my goal, where the feeder line would skirt the garage and then tee into the house water line. Just beyond where I was digging, you can see a small seasonal creek, which had to be crossed. On either side of and while going under the creek, I dug down the maximum depth possible with my termite, perhaps 7, 8, 8.5 feet. I wanted to make sure that any future water erosion in the creek could not possibly work its way down to where the water and electric lines would be located. Here's the view of the mostly covered trench from the corner of my garage, looking back across the creek in the direction of the new shop. The water feed line connected to the house line about 25 feet to the left of this point. Several months later, after the trenching was all done and after the path lights were all installed, this was the view at dusk of the path lights looking from the shop back towards the house. It is extremely nice having a clear lighted path back and forth after dark. Here's another view in total darkness looking from the garage out towards the shop. As part of the lighting, I also installed lights on the corner of the garage and corner of the shop, thus making for a full lighted path in either direction. After installing the trenched water lines, I next built this French drain on the south side of the shop. Ground slope and natural gravity was unfortunately pulling lots of water in this area. The drain solved that by routing the water from the south side to the north side, where it now flows away from the shop. Another important benefit is that the drain now stops much of the groundwater that otherwise would have seeped under the structure. If left unchecked, that could have created future cavities and issues under the concrete floor. Within the trenched gravel, I installed a 4-inch line with holes to collect the water. At this corner, I connected the collector pipe to a 4-inch solid PVC pipe. A second drain collector and pipe, which you really can't see in this picture, also runs perpendicular at this spot. Here you can see the 2 pipes on the west end that take the water away. I also installed cleanouts to wash out mud if that ever becomes necessary. In this final photo, you can see the pipes have been backfilled with just the cleanouts and pipe ends still visible. Once trenching and path lights were done, it was back to getting ready to pour the concrete floor. Previously, the gravel had already been compacted and leveled, so now it was time to lay the plastic vapor barrier and place the rebar on top of that. The rebar I used was about 5/8 inch thick, much more stout and heavier for commercial applications than normal 1/2 inch rebar. As you can see, they were laid out in a strong grid pattern with each intersection tied together with wire. In some places where I knew heavier equipment travel would occur, I placed the rebar a bit closer together. This was a rather long process that required lots of grunt work. Fortunately, near the end, my son was kind enough to drive up from Atlanta and spend a day helping with some of the heavy work of moving the rebar. It was again another milestone moment when the floor was finally ready to pour. The 90% preparation was finally done, and I was delighted the final 10% pour and curing was about to take place. For the pour itself, I hired a local crew who did just an outstanding job. I've poured concrete many times before and could have done it in sections on my own. However, I wanted it done in one pour, and I knew at my age this was beyond my strength. In addition, I was just anxious to get the floor done. Since the prep work had already been done by me, they came in at a very reasonable price. They poured, worked, finished the whole thing in one day. The concrete was mostly about 5 to 5.5 inches thick and about an inch or two deeper around the perimeter, which was about 2 feet from the wall. The concrete I used was a higher compressive strength than what you might use in a normal pour. And as part of the deal, the next day they came back and sawed contraction lines every 10 feet in both directions to a depth of 4 inches. The end result is that even with usage by a heavy forklift, heavy equipment, and so on, there has been 0 cracks in my floor. After the concrete set up, my next immediate job for several days was to fill all the crack seams. Until I actually did it, I really had no idea how much time would be required for this job. A 40 by 60 foot floor with seams every 10 feet in either direction represents 380 lineal feet of crack needing to be filled. And for me at least, the work was backbreaking. You're down on your knees, on hard concrete, you can't go fast, the work is slow and methodical. First, I used a putty knife to force 3/8 inch polyethylene gray backer rod down into the crack about a 1/4 inch down from the surface. Next, I placed masking tape on either side of the crack to keep caulk from bleeding onto the floor itself. You can see the masking tape here in this picture. Finally, the caulk was applied to finish filling the top of the crack. Collectively, the backing and the caulk keep dirt and debris from falling into the cracks, which is great. It's also just a nice finishing touch to the floor. Not everyone does it, but I'm glad I did. And my back and knees were glad when this job was done. If you liked this video, gleaned a few ideas, and want to see how the build proceeded, please hit the like button and go to part 3 of How I Built My Pole Barn Shop. Remember, before adopting any idea, be sure to run it by a qualified professional. And if you're contemplating a project, good luck, and thanks for watching.